Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's algebra class. Today we are going to talk about factoring trinomials, one of my favorite parts of algebra because it's really important. Just like everything, but especially now towards the end, as you've noticed, everything is starting to get combined. Integer operations, exponent operations, factoring, it all builds. And at the next chapter, we're going to use this skill to solve quadratic equations. We're going to actually use this skill to solve problems. So if you don't know this skill, next chapter will be that much more difficult. So please, I implore you, I beg you, pay attention, focus, learn the simple stuff, because then it gets a lot easier as it gets harder, believe it or not. Now, today we're going to learn how to factor trinomials in the form of x squared plus bx plus c. Okay? There is a letter in front of the x squared. It's an a. But today we're going to learn about this type of function when a is 1, so it's invisible. The b is the number being multiplied to the x, and the c is the constant, the number that's all by itself. Okay? So, how does this work? Very simple, my friends. When you have a trinomial such as x squared plus 11x plus 8, you're going to follow the following setup. Number 1, by procedure. My first step is the setup. You're going to look at what you were given. You're going to look at the variable, the leading variable, okay, the highest degree variable. Make sure it's written in standard form. And you're going to go ahead and look at the exponent of that variable, divide it by 2, and you can put an x and an x. Does that make sense, gentlemen? Promise? Okay. Step 2. You got to ask yourself, what number times what other number equals the c value? Remember, 18 is the c value here, positive 18. But when added together equals the b value. And in this case, the 11 is the b value. So what times what equals 18, but when added together equals 11? What would that be, guys? What times what is 18, but when added together is 11? Yes, sir. 9 and 2, that's exactly right. Well, guess what? You just finished. Plug in the answers into the setup. So you've got x plus 9 times x plus 2. Does not matter where you put the 2 or where you put the 9, as long as they have the correct sign. If it's positive, keep it positive. If it's negative, keep it negative. But it does not matter where it goes. Literally, that's it. You're done. It's over. That's how you factor. Okay? Now I'm going to go over it one more time, just to make sure that everyone understands what they have to do. So, my setup. I'm going to put x and x in 2 parentheses. Then I'm going to ask myself, step 2, what times what is the c value, but when added together equals the b value? So what times what is 18, but when added together is 9? 9 times 2 equals 18, and 9 plus 2 equals 11. Those are my answers, so I plug it in. Bada bing, bada boom, I'm done. Does that make sense, my friends? Pretty ridiculously easy, right? Okay, I got a little warning here for you, though. If you guys are not masters of multiplication, this is going to be a lot more difficult. If you know how to multiply like I've been telling you to learn how to multiply, like I've been begging you, this is going to be one of the easiest sections and probably chapters in the whole year. If you do not know how to multiply perfectly, quickly, accurately, this is going to be a very long chapter for you. So please help yourself learn your multiplication tables, please. Yes, sir. Yeah, when you have x squared, that's an x and an x. You're always going to have x squared. If not, you can't factor a trinomial like this. Thank you, my friend. Good question. Thank you, sir. Okay. Now, there are some patterns that you can memorize. You don't have to. I'm going to tell you right now, you don't have to, but it will help. For example, what am I talking about? When you're doing your setup, you could go ahead and put the signs of the numbers if you remember the following setup. When you have an x squared plus bx plus c, when you have a positive b and a positive c, your setup will always be x plus something, because everything's positive. So it's x plus, x plus. When the given trinomial is in the form of x squared plus bx minus c, so in other words, b is positive and c is negative, your setup will be an x plus a number, x minus a number. When the given trinomial is in the form of x squared minus bx minus c, in other words, b is negative and c is negative, you're also going to have an x plus x minus setup. And last but not least, when you're given a trinomial in the form of x squared minus bx plus c, we have a negative b and a positive c, your setup will be x minus, x minus. So when the b and the c are both positive, it's an x plus, x plus. When the b is negative and the c is positive, when the b is positive and the c is negative, it's an x plus, x minus. When both the b and the c are negative, it's an x plus, x minus. When the b is negative and the c is positive, it's an x minus, x minus. You don't have to memorize this. This is eventually you're going to realize the pattern, and it's just going to come to you like clockwork. But this is the way the pattern always goes. Why is it useful? If you have a minus and you end up with an x plus, you know you messed up. Okay? Yes, sir. Someone had a question? Yes, sir, my brother. I'm sorry? Because that's the way it works. That's the way it works. I promise. That is the way it works. For example, if you have x squared here, let's see, plus 2x minus 8. That's going to be an x plus 4 and an x minus 2. Because 4 minus 2 is negative 8. 4 times negative 2 is negative 8. 4 minus 2 is positive 2. And then I can have it over here like this. Whatever I have, x squared minus 2x minus, I don't know, let's see. No, that one isn't going to work. It's kind of hard just to make them up like this, but that's okay. Let's go minus 5x and negative 14. There you go. This is going to be x plus, x minus. X plus, x minus. This is going to be negative 7 and a positive 2. Because 2 times negative 7 is negative 14. 2 minus 7 is negative 5. So trust me, these patterns work. I promise you. I'm sorry, sir? It depends on the sum. Very good. Yes. It depends on what you were given. Okay? Thank you so much for caring. Anything else on this, my brothers? Okay, thank you very much. Now, let's practice, guys. It's the way we make winners here. Let's do it. And I got a class full of winners, so let's do it. R squared, so I got R and R. What times what is 12 when I add together is 11? Positive 6. No, wrong. It's not. Oh, okay, you said 8. Thank you, sir. 8 and 3, you got it. 8 times 3 is 24. 8 plus 3 is 11. Okay, B. Y squared minus 6y plus 8. What times what is 8, but when added together is negative 6? Yes, sir. Well, negative 4, negative 2. Fantastic. Done. Negative 4 times negative 2 is 8. Negative 4 plus a negative 2 is negative 6. Next. What times what is 24, but when added together is negative 11? Negative 8, negative 3. Phenomenal. How about D? What times what is positive 2, but when added together is negative 1? Negative 2 and positive 1? No, because negative 2 times positive 1 is not positive 2. Negative 1 and 2 is not positive 2 either. How about 2 times 1? No, because 2 plus 1 is not negative 1. No, positive 1 and positive 2 is 2, but positive 1 plus 2 is not negative 1. When you don't have a working combination, it's prime. Okay? There won't be a lot like that, but you got to know what to do if it is. Next, what times what is negative 15, but when added together is positive 2? Positive 5, negative 3, fantastic. 5 times negative 3 is negative 15. 5 minus 3 is positive 2. Yes, sir. Oh, yes, sir. What times what is negative 36, my man, but when added together is 9, sir? No. If it's positive 3, negative 12, that would be wrong, because 3 minus 12 is negative 9. So it would be positive 12 and negative 3. Very good, son. Well done. See, you got to be careful there, my friends. He had said negative 12 and 3. Negative 12 times 3 is negative 36. Good job. But negative 12 plus 3 is negative 9, not positive 9, okay? So be careful with that, please. And thank you. Okay. What times what is 30, but when added together is 31? It is not prime. Positive 30 and positive 1. Okay, guys, remember what I had said. You're very rarely going to get prime. Thank you, sir. Now, here's the problem, though, guys. A lot of times, people will look at a trinomial. They're not very strong with their multiplication. If they don't get it in 2 seconds, they'll just say, okay, it's prime. No. Very rarely are we going to have prime. And before you can say with certainty that it's prime, you have to go through every combination possible. Please be careful with that, gentlemen. Okay, next. What times what is negative 40, but when added together is negative 3? Negative 8 and positive 5. Phenomenal. Well done. Well done. Next, what times what is negative 15, but when added together is negative 2? Negative 5 and positive 3. Very good. Negative 5 times 3 is negative 15. Negative 5 plus 3 is negative 2. Last but not least, what times what is negative 20, but when added together is 8? Yes, sir. Very, very good, son. X plus 10 and x minus 2. That is fantastic. Well done, my man. Well done. Does that make sense, my brothers? Okay, may I continue, gentlemen? You sure? Because I got plenty of time. Okay. Now, factor each trinomial if possible. If not factorable, write prime as the answer. However, remember what we talked about yesterday. Whenever you're factoring, okay, always, and I mean always, remember to factor out the GCF if possible. Factor out that GCF if possible. So, of course, in all of these, there's a GCF because I want you to practice it. What is the GCF for A, my brothers? 5. So first factor out of 5. So that means I divide every single term by that 5. Now I can factor. What times what is negative 32, but when added together is negative 4? Come on, guys. Don't leave me hanging. No, not positive 8. There you go. Negative 8 and 4. Very good. Negative 8 times 4 is negative 32. Negative 8 plus 4 is negative 4. Next, for b, what can I factor out of there, my brothers? And my sisters out there in the internet world. Negative 3, yes. So I'm left with x squared plus 2x plus 8. Okay, what times what is 8, but when added together is 2? 2 and 4? No, 2 plus 4 is not 2. No, it's not going to be 2 and negative 4 because negative 4 times 2 is not positive 8. So it's going to be prime. But you cannot write prime in this example. Why? Think. Didn't I factor a GCF out? So, okay, this part here is no longer, you can't do it. But since you already factored out a negative 3, you just leave it like that. So you do not say prime in this case. Why? Because I factored out a negative 3. If you can factor out a GCF, that's it. It's no longer prime. Prime is when you can factor nothing out. This is the answer. That is that answer factored out as much as you can. Sometimes all you can do is factor out a GCF, my man. Sometimes you could do it all. Next, what can I factor out of here? Do I have a GCF, my friends? Absolutely. So I've got x squared minus 2x minus 24. What times what is negative 24, but when added together is negative 2, my friends? Come on, guys. Don't leave me hanging. I know you can do it. There you go. Negative 6. See, you don't need me. You got this. You don't need me. You got this. Proud of you. Last but not least, what can I factor out of there? Out of B, out of D? Heck yeah, 7. So I got x squared minus 2x plus 1. This is a good one. What times what is positive 1, but when added together is negative 2? No, negative 2 times negative 2 is not positive 1. Negative 1 and negative 1. Very good. Now, how can I rewrite x minus 1 times x minus 1? Very good, my brother. That is exactly correct. Isn't that what we just finished learning, guys, in the last chapter? X minus 1 squared, doesn't that mean x minus 1 times x minus 1? So if I see a repeated binomial being multiplied, I can go ahead and use my my exponent to represent that. Does that make sense? Awesome. Thank you, guys. Okay, we got plenty of time to practice. So let's take a snapshot of that. Let's practice. I'll walk around, answer any questions. Thank you very much. Hope you learned a lot.